Welcome to another session of Everyday Mathematics. Today's problem is problem number 15 from the MI 2024 integration B regular season, which is the definite integral from x equals to negative square root of 3 over 2 to positive square root 3 over 2 of the integral of 2 in bracket 1 minus the absolute value of x over root 3. Very interesting problem. But also very simple. We're going to show you two different ways of trying to approach this problem. Before I go there, I'd like to thank our subscribers. Thank you so much for your support. We don't take it for granted. We like your support. It's giving us that extra visibility we need for first-time visitors. We like to inform you that here at Everyday Mathematics is we love mathematics. We go about and around and look for interesting problems. And we come back and we share with you the solutions that we do think befit the problems. Our repeating visitors, if you haven't subscribed, we do really encourage you to consider subscribing to our channel. So the first way is to plot a graph of the integrand. And so if we have y and x, the absolute value of x over root 3 is going to be like this. So the positive value, you have this line that has a gradient of 1 over root 3. Negative side, instead of the y equals to x over root 3, which would be a negative, it's positive because we're getting the absolute values of the x's. So in other words, it's a mirror image of whatever is on the positive side along the y, the x equals to 0 plane or the y-axis. Now, therefore, 1 minus x, absolute x over 3 is going to be like this. So at 0, where the graph x root absolute x over root 3 is 0, 1 minus that is equals to 1. And when this graph is 1 is when this entire graph crosses 0 and continues like that all the way in the negative direction. So therefore, these graphs cross each other at root 3 over 2, negative and positive, right? So that the area under the graph between this root 3 negative over 2 and root 3 over 2 positive is going to be equal to this rectangle, the area of this rectangle, and then plus the area of this triangle, right? Times, since we have this constant 2 that has come out, times 2. So this is essentially what is going to happen. Now, the area of the rectangle, the length is twice root 3 over 2, which is root 3 here, length. And the height, midway, is a half times a half. And then for the triangle, a half base height, which is a half is a half, and then the base is still root 3. The height is going to be a half. As you can see, these 2 and these 2 cancel. These 2 and these 2 cancel. So we're going to be left with root 3 plus root 3 over 2, which is 3 root 3 over 2. And this is the answer that was expected. Very easy, no nebulous calculus involved, just area of the shapes. Method 2, we could split this integral into two subcomponents, the negative side and the negative side, because you're looking at the absolute, so it becomes a negative of the x. And the positive side will just remain with the x. So we have negative root 3 over 2 to 0 and 0 to root 3 over 2. And so this becomes positive. Negative, negative is a positive, and then this remains as it is. And if we say that let x be equal to negative x prime, such that dx is equals to negative dx, right? And the limits, negative becomes a positive, And so this becomes negative dx prime, and then this becomes negative dx, and this becomes positive. We get integral negative, because this negative here now comes here, 2 times the integral from x equals to 3 over 2 to 0 of 1 minus, this minus here is here, x over 3 and dx. Now, this sign can be removed by flipping the limits. So we have 2 times the integral from 0 to 3 over 2 of 1 over x over 3, and the same thing happens here. So eventually we just do have twice that, which is 4 times the integral from x equals to 0 to 3 over 2 of 1 minus x over 3. And then these are easily integratable variables. So 1 becomes x over 3 is x squared over 2 root 3, with the limits root 3 over 2. So 4 root 3 over 2 in place of this x here. And then root 3 over 2 squared, root 3 over 2 squared over 2 over root 3. And as you can see, one of the root 3 in the square here cancels, and so we left 1 root 3 here, and then this 2 squared is 4. 4 times 2 is 8. So we have 4 outside here, root 3 over 2 minus root 3 over 8. And when you multiply across with the first here, we have 2, 2. So we have 2 root 3. 4 and 2, so we have a half, so root 3 over 2. So 2 root 3 minus root 3 over 2. And so this is same as 4 root 3 minus root 3 all over 2, so which is root 3 over 3 root 3 over 2. And this is also a final answer. So very interesting solutions. One involved just plotting it out, and that was a simpler method. But the next one involved really grinding through the calculus, which is not really hard, but it needed extra interpretation of things. So until next time, I would really appreciate your continued support. Stay tuned and take care. Bye-bye.